We can write safely and read safely. But every one of those operations skipped a question. Is the caller even allowed to do this? That's authorization, and it's not the same as authentication. Authentication asks, "Who are you?" and checks your badge at the door. Authorization asks, "Now that we know who you are, what are you actually permitted to do in here?" Get it wrong in the lax direction, and anyone can cancel anyone's order. Get it wrong in the strict direction, and your warehouse team can't ship anything. Let's get it exactly right. The first layer is role-based access control, and it's the course gate. Every operation declares the permission it requires. Submit an order needs orders:"submit. Cancel needs orders:"cancel. If the actors granted permissions don't include it, the request is rejected with 403 forbidden before your handler runs a single line. That's the key move. The permission requirement is declared on the operation, and a pipeline enforces it. It is not an if statement buried in the handler that someone can forget. And because permissions are part of what your system means, they live as constants in the domain layer. So there's exactly one place that names them, and the command and the policy can never drift apart into mismatched magic strings. But permissions alone are too coarse. Consider cancel. Holding orders:"cancel can't mean you may cancel everyone's order. It means you may cancel your own. That answer doesn't depend only on who you are. It depends on which order this is. That's resource-based authorization, sometimes called attribute-based. The rule reads the resource. Are you the actor who created this order? If not, do you hold the admin permission that lets you act on anyone's? Because it needs the actual order in hand. This check runs a little later than the permission gate, after the resource is loaded and before it's mutated. 2 layers. In order, the cheap permission check first, and then, only for the operations that need it, the ownership check against the loaded resource. Here's the part juniors skip and seniors insist on. Before you write any authorization code, write the matrix. Every operation, in a table with 2 columns, the permission it needs, and whether it also checks ownership. The moment it's a table, the bugs surface. Trap 1. It is tempting to put an ownership check on everything, but approve, ship, and deliver are done by a warehouse manager who did not create the order. If those were ownership gated, no one could ever fulfill an order. So they're permission only, by design. Trap 2. This spec has both an orders read and an orders read all permission, and if read all doesn't subsume read, an admin who only holds read all gets denied a plain single order read. The matrix is where you catch both, on paper, before they become a support ticket. And remember, the spec itself can be wrong here. We fixed exactly these 2 in ours. Here's the course gate as code. Approve order command implements I authorize and declares one required permission, orders:"approve, and that's the entire authorization for it. Deliberately no ownership check, because the person approving is warehouse staff, not the order's creator. Get it on ownership and the workflow deadlocks. And notice where the permission name comes from, a permissions class in the domain, a single set of constants. The command references orders:"approve by that constant, and so does whatever grants it, so they cannot drift. The pipeline reads the required permissions and returns 403 if the actor is missing it. You declared the policy, you didn't write the check. And here's the resource check. Cancel order command needs the orders:"cancel permission, the course gate, and then it implements I authorize resource, which hands the rule the loaded order. The condition is exactly the sentence from the matrix. You may cancel this order if you are the actor who created it, is owner against created by actor ID, or if you hold read all, the admin permission. Anything else is a 403. The framework runs this at the right moment, after the order is fetched, before it's canceled. So the 2 layers compose cleanly, permission first, then ownership, and both are declared on the command, readable in one place. Instead of smeared across the handler as hand-rolled if statements everyone forgets to keep in sync. So authorization is 2 layers, in order. A course permission gate that every operation declares, miss it, for 103, before the handler runs. And a resource check for the operations where the answer depends on which order it is. Are you the owner or an admin? Declare both on the command. Keep permissions as domain constants. And above all, write the matrix first. It's where you catch the traps like permission-only fulfillment and read-all subsuming read, on paper, cheaply. Next episode, the hardest correctness problem in the whole service. saving your data and publishing an event atomically, the outbox. Subscribe, and I'll see you in episode 6.